look now at the written calculation method for division in Year 6. So in Year 6, the children continue to use the formal short division method, or bus stop as the children call it. They know this method really well now from Year 4 and Year 5, so it's securely in place. The difference in Year 6 is the way we work with remainders. So before we've recorded the remainders with a little R on the answer and recorded the remainder as a numeral. In Year 6, the children are expected to express that remainder in a number of different ways. So depending on the question type, or sometimes in a stats paper it might be determined how they should record it, they might be expected to give it as a fraction, or they might be expected to give it as a decimal. So if we look quickly at the method that the children used in Year 5 and how they would record a remainder with the R, I can then show you that against how they are expected to record it as a fraction and decimal, so you can see the similarities and how that works. So set up our bus stop over here. We're going to look at the calculation. 475 would probably work better. 11, 5, 16. No, let's go 6. 476. I'm just thinking of a good example that gives us a good remainder to work with so that I can show you what we need to do. Let's divide that by 3. So dividend, waiting in the bus stop, divisor is the bus driver coming to collect it, and we'll work through this as we would normally in Year 5, and the children should be really secure with that by now. We're thinking about, rather than sharing this number into 3 groups, we're thinking about how many lots of 3s can I fit into 476. So we need to think of it that way for the method to work. So how many 3s can I fit into 4? Obviously we know this isn't a 4, this is a 400, but by Year 6 the children have such a secure understanding of the place value of numbers by now and how the methods work as they've built on the methods each year. Actually, it's much more efficient if we can just think of those digits in isolation, and it helps this method to work as well. So how many 3s can go into 4? I can fit 1 3 into 4, and I have a remainder of 1 left over. Children should be really secure by now with working out the remainders to carry over. If they're not, I can draw 4. How many groups of 3? Well, I can make 1 group of 3 then, and I have 1 remaining left over. Okay. How many lots of 3 can go into 17 then? Well, 3, 6, 9, 12, 15. I can fit 5 lots of 3 in. And if I got to 15, but I was working with 17, I will have 2 remaining to carry over. How many 3s fit into 26 then? 3, 6, 9, 12, 15, 18, 21, 24. Sorry, 8. Let me slip there. 8 lots of 3s can fit into 26, and there will be 2 remaining. So in Year 5, we're used to recording it like this. Remainder 2. So if I show you the same calculation now over here, but we'll look at that remainder as a fraction. So 3s into 4s, I'll just quickly whiz through this part because we've done it all over here. 3s into 17 go 5 with 2 remaining. 3s into 26 go 8. I now have that remainder of 2 still, but to express it as a fraction, all I need to think about is I have 2 left over, and I still want to divide that by 3, as I have done all the other numbers. And there, quite easily, I have my fraction. And that's what fractions are. Fractions are division. This line means divide by 2, and I'm dividing by 3. You can see it looks like the division symbol. A line with something on the top and something on the bottom. And that's how we get the children to think about it. So whatever my remainder is, stick the line. This is my numerator, what my remainder was, and my denominator is what I was dividing by 2, still divided by 3 to get the fraction. If we look at that as a decimal then, this is where it gets just a little bit trickier. So, same calculation. Again, I will just quickly whiz through, because we've done this part. It goes 5 with a remainder of 2, it goes 8, and we've now got a remainder of 2. With that remainder of 2 for a decimal then, what we're doing here is placing a decimal point. I have my hundreds, and you could put the place value headings to support my tens, my ones. I'm now going to start recording numbers that are smaller than a 1. So I need a decimal point as I go into my tenths and my hundredths and my thousandths. Okay, so decimal point to record, we are going further to the right than the ones column. That 2 then, I want to carry over still. I want to bring it into the next column, but I don't have any numbers here to do so. As with any decimal, as long as there are no other digits involved, I can place a 0 on the end of that number, and I'm not changing the number. I still have 476. The point 0 makes no difference there whatsoever. So I can record a 0 without it changing the maths behind what we're doing. That means then that this 2 remainder that I have has a digit to move over to. So I can bring the 2 over to here. So I now have 20 tenths. I can now think about, well, how many 3s go into 20? 3, 6, 9, 12, 15, 18. I can fit 6 in. And I have 2 left over. I have nothing to bring that 2 over to, but again, I can add another 0, and I can add as many zeros as I like, as long as no other digits are involved. I'm not adding any other digits into that number, not placing any other digits, sorry, then it's not going to affect the value of that number in any way, but it does give me something to bring that remainder of 2 over to. So again, I can go how many 3s into 20? Well, of course, again, it's 6. I've got another remainder of 2, and that's going to carry on and on, isn't it? At that point, we'll stop the children and introduce them to the recurring symbols, the little dot up here, as a recurring.